Hi, I'm Avery Fowler, and I will be doing my presentation on emulation. As many people know, software and hardware are not entirely universal. The more different types of files and systems that you try to run on your computer, the more roadblocks you will run into. Not everything can be opened, and even if it can be, it's not legible. And sometimes systems will block programs outright, as with new Mac OS. It can only run 64-bit programs, which meaning 32-bit, 16-bit, etc. A lot of older programs are just outright not being able to work. Some even modern ones that are still being developed. And what is the solution to this issue? Emulation. The definition of emulator being hardware or software that permits programs written for one computer to run on another computer. Why this may be? Because people may need to access software that may not work on newer operating systems. And emulating the OS is easier than making it software compatible. There are tons of programs out there that either the studio that was in charge of it or then developed it either ran defunct or stopped giving support for the software. And this leads into issues of what if I still need the access? What if, well, that's what an emulator is for, or and why you would emulate the OS rather than making it software compatible. There are tons of steps on taking old software and turning it into something for a new system that we'll get into. Now, before we get into that, we will talk about a cousin of emulation, virtualization. Virtual machines accomplish the same goal as an emulator, just through a very different method. They take a bit of your CPU's processing power, isolate it, section it off, and then from there you run an operating system, whatever you need, usually an operating system. And why this may be, there are tons of uses. One of them being safe server storage space. Essentially, you section off bits of a server for different use, and through a virtual machine, and this will create more space to use. So if you may not need all the space as a processor, all the processing space for the server, and that it has in one chip or one bit of hardware. So you section it off, and it makes it more, and it saves space and it saves money. It can also be used for testing applications, such as if you have a piece of software that may not be the most safe to open or you're unsure of, running it in a virtual machine, since it's isolated, is completely safe. If it causes any problems, you can just close it, and the virtual machine, that is, and no more issues will return. It can also be used if you're working on something that messes with the application that messes with the operating system in a way that may break the operating system or crash the system or cause damage to it. Then again, everything will be safe. Your computer will be safe because it won't be at risk due to it being isolated. Now, back to the problems with older software. There are tons of issues with old software that are beyond just it not launching or closing on launch. For example, I own this game from 1998 called Shogo, up there down here in the corner, and there in that game, it is no steps have been taken to emulate the game on a modern system outside of the steps that Microsoft has done to put backwards compatibility in Windows 10. and here's a video of all the steps I had to do to get it up functioning.
But my game didn't look like this at first. It looked like this. Shogo is a good example of one of my golden rules. Just because you could buy it on GOG doesn't mean it's going to work. So this is the retail version, and this is after I tinkered with it. So out of the box, it doesn't play well on modern systems, but it can, and there's a lot of people who don't know this. I thought it would be a good idea to list off how I made this happen. Otherwise, you're stuck playing in a windowed mode at about 11 FPS. Shogo doesn't support full screen, but it does support this size, which I'm going to call Planetarium. The first thing you need to do is download the widescreen patch, which some guy in a forum made. It's pretty easy to enable in the launcher, but we're not done yet, because the resolution is right, but now the menu is laggy, and the game will be too. DG Voodoo Wrapper is the savior here. It's a wrapper for older graphics APIs, and you can get it for free. The one drawback is almost every browser will scream at you that it's a virus, but you can just ignore that. Trust me. So once you've copied the right files in and got it all configured, you then choose the new display in the menu. So now it runs great, but the controls need work. It's like System Shock, where A&D turns you instead of strafing. But then I realized that clicking wouldn't shoot. It's a keyboard input and it won't let you rebind to a mouse button, unless you load some lines into the game's auto-execute file. Now this wasn't picked up by recording, but sometimes the mouse would start flashing in the center of the screen. Another common problem. But instead of downloading some program to fix that, I just made a blank mouse cursor and used that. There's also an issue where the endgame soundtrack won't play. Running that in Windows 95 compatibility mode fixed it for me, but your results will vary. So yeah, now the game's running. I might end up buying this on Steam just so I could post a community guide there that has all the fixes in one place. If you couldn't tell, it was a little bit of a scavenger hunt to get this going, so now I could find out if all the trouble was worth it.
Well, now if you missed any of it, the list of issues being it had extremely low frame rate, uh, and it could only be played in windowed mode and with an extremely low resolution. No mouse support for a first-person shooter, which is unheard of for any modern standards. A flickering mouse issue and no music. On top of that, he installed everything that he installed and I installed to get this game running had to be developed. The graphics wrapper, the full widescreen patch, and how to give it mouse support all had to be made developed, which people did on their free time. So on top of that, there's quite a few issues. Now, to avoid this, again, we use emulators to do a lot of this for us. And how do emulators work? Uh, Emulators use software to recreate hardware as software. This is extremely popular for things like game consoles. I personally used these two emulators below in my lifetime, where Dolphin emulator and a Game Boy emulator called My Boy for Android, with and as with game consoles being what I've mostly used. So this is where my experience comes in. There are two different types of emulators, low level and high level. Low level is the most common version. It simulates the hardware using the software. This makes it extremely close to the original, which sounds nice but can lead to issues, as we'll get into later. With the high level, which simulates the function rather than a true to life simulation. This allows you to take advantage of a more modern system, as with previously with a Dolphin emulator, which is a emulator for N64, GameCube, and the Wii. A modern system with the latest hardware is significantly more powerful than an N64 or a GameCube or a Wii, and therefore, with a low-level emulator, it won't be able to take advantage of all of that, while the high-level will be able to take advantage of all those new technological advances. And this makes high level extremely much harder to make than a low level. That being said, low levels are still very useful. Now the issues are emulators don't usually run as well or as smoothly as their original systems, with most people using low-level ones. Personally, I've experienced this with playing. I'm a big fan of the F-Zero racing game series, and the F-Zero game on the GameCube. I experienced a lot of lag, a lot of frame drops, which I do not experience both on the original version, the copy of the game when I played it, or on newer games that are definitely much more taxing on the computer. This is due to how the CPU works with an emulator. The CPU has to translate instructions from the emulator into something that the computer can run. Think of it as having a conversation with someone from a different language that speaks a different language. You have to talk to a translator who talks to that person who responds through the translator back to you. While it works, it may not run at peak. It doesn't work efficiently. It's not necessarily efficient as if you would both speak the same language and you can just bounce back and forth. This is essentially the same thing. With the extra steps of everything being translated, it may produce lag. With the more advanced something works. That would be all. These are my sources for all my information, and thank you for listening.